Mantises look like they should be straightforward. Small insect, sits still, catches things, but the moment you look at the actual biology underneath, how it sees, how it strikes, how it reproduces, almost nothing works the way you'd expect. Start with the eyes. A mantis has 5 of them. 2 large compound eyes dominate the face, and 3 smaller, simple eyes sit clustered between them, detecting light and motion at close range. But what makes mantis vision genuinely strange isn't the number. It's what those eyes can do that no other insect on Earth can. The mantis is the only insect known to see in 3 dimensions. Every other insect lives in a flat, motion-detected world. The mantis perceives depth. But when researchers at Newcastle University investigated how, they found something nobody expected. They glued tiny 3D glasses to mantises using beeswax, one lens filtering blue, one filtering green, and showed them moving images of prey. The mantis could judge depth and strike accurately. Then they showed it still images. The mantis ignored them completely. It couldn't process static depth at all. Mantis 3D vision isn't like ours. Human stereo vision works by comparing 2 slightly different still images from each eye and calculating the gap between them. Mantis vision works entirely on movement, scanning for where things are changing over time rather than where they are in a fixed frame. It is a completely new form of 3D vision, previously unknown in biology, discovered only in 2018. Scientists are now building robot vision systems based on it. To use this vision effectively, the mantis needs to track targets without moving its body. That's where the neck comes in. Mantises are the only insect capable of rotating their heads independently, up to 180 degrees. Every other insect must move its entire body to change its line of sight. The mantis simply turns and watches, tracking prey with a stillness that makes it nearly undetectable. And then it strikes. The forelegs of a mantis are raptorial, purpose-built for capture, lined with interlocking rows of sharp, backward-pointing spines. But the real engineering is in how they fire. Instead of relying on constant muscle contraction, the mantis stores energy in its limb structure like a drawn bow. When released, that energy delivers a strike lasting between 50 and 70 milliseconds. Faster than a human blink, faster than prey nervous systems can detect and respond. Research has documented mantises capturing animals up to 138% of their own body mass. Some larger species have been recorded taking small birds. But the strangest part of mantis biology isn't the hunting. It's what happens afterward. Sexual cannibalism in mantises is real, documented in roughly 13 to 28% of natural matings in the wild, with some species reaching far higher rates. The female will often begin eating the male during mating, starting with the head. Popular culture treats this as simply brutal. The biology is more unsettling than that. The male continues mating after decapitation. This is not a reflex twitch. The neural centers governing mating behavior in mantises aren't located in the brain. They're distributed through ganglia in the abdomen, which operate independently of the head entirely. Removing the head also removes the brain's inhibitory signals, meaning a decapitated male may actually mate more effectively and for longer than an intact one. Some males have been observed mounting females and initiating mating after their heads have been completely removed. The body completes the task the brain was never fully in charge of. From an evolutionary standpoint, this arrangement makes a grim kind of sense. A male whose body is consumed by the female provides nutritional resources that directly increase the likelihood of his offspring surviving. His genes continue. He just isn't there to know it. The mantis is an animal that has compressed extraordinary sensory architecture, mechanical engineering, and one of the most confronting reproductive strategies in the natural world into a body the size of a human finger. It sits completely still on a leaf and looks like nothing is happening. That appearance is not accidental. It is the whole strategy. It does not look like much. It never does. That's the point.